Python tends to, so if I have a variable, which is, let's say, string, let's say Shade, stored as a string. When we say something is an index, we try to look for the position of that thing in that string. So if I say, what's the position? So if I do the position of X, so what do I do? X.index, then I'm looking for S. So it tells me what the position of S is in that string. It tells me S is in number position 0. If I'm looking for the position of E, what do I do? Can you see E is in number 4? Now, the trick is, this is really important because it helps you find something in a string. So if I come here to do, okay, now I know the position of E. If I want to pull out only E, all I have to do is, good. Can you mute yourself? I can't. Udunola Akimu, can you mute yourself? Thank you. So if I do X of 4, automatically it brings the value of E. So we could use this to find the position of a value. But here's the problem. The problem with this is the fact that what if I have X is defined as Femi or $10 or let me spell it very well. $10 in case we have someone who knows the family. So now the problem is, if I'm looking for the position of E, there's a problem. So I'll do X.index of E. So position of E. Now the problem here is the fact that it's going to pick out only one position of E, which is the first one. What about this E? You could see that there's a problem, So how do we find position in a string? First of all, we're starting with strings first. We're going to look at list. How do we find position in a string such that even if the values are repeated, we can actually know the position of those values? We can know how many times there is this in that string. So it's simple. So there's something called enumerate. So Python has an enumerate. So if I do for J in, you could see enum, I think of X. Let's see. Let me print J. So you can see what happens here. When using enumerate, what does Python do? Python prints the position of each of those values, together with the value itself. So you could see that it's telling you that E here is in position 1, but we have another E again, which is in what? In position 6. So if I want to get the position of only E, this is where conditional comes in. I'm going to do something like this. So we're using for loops and conditional. We're going to say if, now I can do J of, now I'm going to show you something. So this method, what you're seeing here, Python calls anything you put inside a bracket like this, it calls it a tuple. That's what Python call it. Now, I'm going to explain difference between tuple and list when we come there. Hold that thought. Tuple, and when you see something like this, Python calls it a list. Both of them can be interchanged, but both of them are used when you're building a software, you use them for different purposes. Now for tuple, we say a tuple is immutable. So what do we mean by something is immutable? So we're simply saying that if you store something inside a tuple, don't worry, you cannot change it. That's where it is. Nothing can happen to it. But if you store something in a list, what happens? You could change the values you've stored inside the list. So that's how we use both of them. I'll look for a good example and show you. So if I have a tuple, that has, let's say, a value, A, comma B. What happens here? And I call this Z. And I want to find the position of B in this tuple. Or I can just do Z of B is number 2. Sorry, number 1. So what happens here? Z of 1, it brings the position, which is B. Now, how does Python store values inside tuples and lists? It starts from the index of 0 in memory. So the first value is in index 0, the second value is in index 1, the third value is index 2, just like that. So just know it starts from 0. Now, if you're starting from behind, it starts from -1, it starts from -1, -2, -3, -4. So 1 here is the same thing as, so if I let me put something like C. This same thing you're doing here, we can use it for a list, we can use it for a string, this index processes. So if I put 0 here, what happens here? It picks A. If I put 2 here, it picks C. If I put -1 here, it still picks C because from the back, -1, -2, -3. From the front, 0, 1, and 2. Now just have that thought at the back of your head. Now for this enumerate, you could see if I want to pick only, you could see from the results here, when I printed J, you could see the index showed here and the value showed here. So if I want to find only the value of E, only the values, like enumerate X, remember, X is femio-orthogonal. So if I want to just find only I can say this is the index. It's a tuple. So it is stored at the first one is stored in the 0 position, the second one is stored at the first position. So if I do of 1 is equal to, and I do E, print J of 0. So what am I simply saying here? I'm simply saying that, oh, let me take this guy and keep it here so I can explain what we're doing. This might not be clear to you, except you watch the video again. It will be clear to you again. So let me print J. Don't let this whole thing bother you, because I think when we solve a problem with it, it's going to make sense. So remember, X is femio-orthogonal, which is stored in the variable X, right? And what happens here is, let me bring it closer so that it will be easier for you to see. Just cut this guy and bring it closer. I'll explain, when we look at for loops, I'll explain a little bit more about for loops. So X is femio-orthogonal. Here, if I'm looking for the position of E, here, it just shows you 1. But we know that E is contained multiple times here. Now, but for me to find all the times we have E, the first thing I have to do is to enumerate the value of X. Enumerate means bring out all the values of X together with their indexing. So you could see that how we brought it there, it brought them in tuples. You can see. Now, if I say, okay, I'm only looking at the first index, not the 0 index. The first index of each of them. Check only the first index and find E. If you see E, print the 0 index. So what it does is it comes down here and say, okay, I saw E here. Okay, since I've seen E, what am I printing? I'm printing 1. It goes again. I saw E here. Okay, since I saw E, what am I printing? I'm printing 6. So technically, you could just have, these are the index. The index are what? 1 and 6. Now, I could just keep this value here. I can do new value. Let me call it new index. And I can create an array. I'm going to explain what I'm doing here. I can say array index. So Python has what they call append. So the whole idea, what I'm doing here is I'm storing this value now inside an empty array. I want you guys to understand something. This might be a little bit difficult for you to capture. Why? Because, I'm not trying to go through the basics. I'm using examples that we're going to be using so that when we start solving problems, you could relate to those examples. So on your own, what you do for me is basically go back to the video, look at these examples I've used, understand them and write them. That's the only way you could actually catch it. So here, I'm going to explain what I'm doing as we go further, don't worry. So I put new index. So what am I simply doing here? So if I print, I can print array index. So I'm gonna just, so it prints this guy 1 and 6. So what you're simply saying, what you've just written here is a simple program to get the index of. So now, if I want to get E, now I'm gonna explain. If I want to get E, I already know the index of E. So I can come here to say, keep the X here. I know that X of 1 will give me, and also 2, X of 6 would give me E. So both of them will give me E. So let me just put it here so you could actually see what I'm doing. So I'm going to do something simple just to explain what I'm trying to do. Then we can just So both of them will give me EE. So which is basically all the E's in Femi Otodola. But if I just did X of index of E, what happens? It just point me to the position. But with this enumerate, I could get the position of all the index, which is position 1 and position 6 for the index. Here, it will just give me only position 1. Now, I introduced a couple of things here. One of the things I introduced was append here. And what is append? Simple. I'm just going to explain how append works. So append. Now, append will help you a lot because if you're taking something from a list and putting in another list, you're appending. So let's say you have this is a list. Let's say you have a list. Let's say A is a list 1, 2, 3, 4, and you want to store a value inside this list, like A dot append. So let's say you want to append 5. So what happens here? You print A. You're going to have a new list 1, 3, 4, 5. So append basically just takes values and store inside a new value. So I want to show you two types of Python function. Now, some Python function, notice you're going to, for example, I'm going to show you two types of Python function. Then when we get to that point, I'm going to explain it. So far, so good. What I'm trying to show you is how Python indexing works. All I want you to take away from this is the index method of Python. So index method of Python can work in a string. I'm just going to put it here. It can work in a string. It can work in a list. It can work inside a what? A tuple. And I explain what a tuple is. A tuple is just use the bracket sign as connotation. So, for example, if you have name, let's say new name, Ben, and if I do new name of 0, what does it bring for me? It brings B. Now, this is for a string. Now, for a list is basically a collection of data type. So, what's a list? You say list, collection of data types. So, for example, I can have list, and this list can contain a data type Ben. It can contain 25 or 23. It can contain a Boolean true. It can contain 0.45. So it can contain every type of data type. In fact, this list can even contain a tuple 4,6. It can even contain a set. I know I didn't talk about set, but just have that at the back of your head. A set. Inside that set, you can actually have James, Kate, and let's say false. So a list can contain anything. So it mustn't just be. So here, what happens is automatically Python stores each of these values, each of this unique data type in an index, and that index. So if I do list of -1, what will it print? It's going to print the entire set because it's a collection of data type. So what happens here? This entire set. So if I do list of 0, what happens here? Python prints only this data type, which is a string, Ben. Can you see what's happening here? So if I want to print E here, all I have to do is 0 of 1. So Python prints the first one, it prints Ben. The second one, it slices through Ben to find what the position of 1 is. So you could play around indexing the way you want to. Just know that Python stores values. If it stores values in the data type, it stores them in an index position. There's a far more complicated explanation, I have to start explaining, how computer RAM works, and how it's being computed. So, but that doesn't concern you. But for now, all you have to understand is Python stores values in a variable. Those variables holds data type, and we can actually find the position of the data type, based on the indexing. So that's what you need to understand. And also too, when you hear something called a list is just a collection of data type. So what happens is, and we can actually use indexing to actually find the list. Now, the cool thing about indexing is the fact that you can slice through a list. So for example, you have a list of numbers. Lists can be quite complicated. In fact, as a matter of fact, lists are quite complicated as we go further. But for this course, I won't go into you're not doing neural networks, so there's no need to start explaining. Most of the things you want to do with lists, NumPy can handle it. NumPy would help you play around with complicated matrices, which is basically what we call a list. So you don't even need that. So when you look at NumPy library and you study it, you're going to see a couple of things you need to find out. But for this particular course, we're using this just to understand what we're supposed to do. So for this guy, if I have a list of, let's say, numbers, let's say 8, 10, 4, 15.5, 9. Now, and these are the numbers, and I want to slice through this number. What is slicing? Slicing simply means start with position 1 and end in position 3. What does Python do? Python says, okay, since you want me to start with position 1 is 10. I'm going to pick 10. So I'm going to pick 10. I'm going to pick 4. Are you getting me? But I'm not going to pick 15.5. So I'm going to stop in position 3, but I'm not going to pick it. So that's how Python works. So Python is going to pick just 10 and 4. Are you getting me? So this is what we call slicing. So always note, because the difference between the 10 and 4 is 2. So that means just two numbers here. So Python is going to pick starts from 1 and end in 3. It's not going to pick 3. If you're not going to pick the position of the position of the 3 is 4. So it's picking based on the position. So if I include this guy, so start from 1 and end in 4. What does Python do? It starts here. Where is 1? It picks 1. It picks 2. It picks 3. But it doesn't pick 4. Why? Because if you count 0, 1, 2, 3, right? If I count 1, 2, 3, 4, but this is going to be confusing, but just know that it doesn't pick the last number, which is, just know that. So have that back of your head. So 10, 4, 15.5. So that's how Python works. So this will help you slice through data types quickly, just to go through them as you walk around. So now, the trick behind this is, you have questions, so I can answer your question before I move further, because I know I've talked about a couple of things. Any questions so far?
Okay, so just for clarification, please can you hear me?
I can hear you.
Okay, so the first number starts with 0, not
Yes.
1.
Yeah, the
All
first
right.
number, yeah, 0, yeah. So it's a hidden index. That's what we call indexing. So it's a hidden index. So it stores it in position 0. Are you getting me?
Okay.
Then 1, then 2, then 3, then 4, just like that to infinity. So computers
All right.
start counting from 0. So yeah. So number 8 is in position 0. Number 10 is in position. So that's how it works. Is that clear? So
Yes, it is. Thank you.
okay, so I'm going to keep this information here. So remember what we did with enumerate, don't forget it, and what we did with append. So I'm going to keep all this information here, and I'm going to come down here, and now we can work on list, because we're going to work on list a lot. So list and for loops, just to get an idea on what we're doing. So when you say something is a for loop, what does this implement? A for loop is just like, you have, the simple way I could put it so you understand, you have a basket of balls, different types of balls, red ball, green ball, you know, um, different types of colors. Now, a for loop, if I write a for loop for that basket, what for loop does is it just brings each of the ball one after the other. That's all it does. It just picks each of the ball one after. So it just picks all the ball one after the other. That's all it does. Except I set the condition to say, okay, you're picking each of the ball. Why not pick only blue ball? You know, say, oh, if I see red ball, I'll keep it back. Then I pick only the blue one. So for loop is just an iteration. Go through everything you find there quickly. That's how it is. So for example, if I have x is equal to 1, 5, 4, 9, 10, 3, 2, 11, and usually I can do x of 0, 1, x of 1, x of 2. Like this will take us 3 generations to finish, especially when you're going through a large number of lists. Now, but if I write a for loop for I in x, that's all. Print I. So what's I? I is anything. Can you see? It just brings all the values out. What I? I just means I is just a variable defined. It can be B, it can be C, it can be anything Z, it can be J, it can be anything. So the key thing here is the X. So this is how you write a for loop. Now, but if I say, okay, for this my for loop, I just want to pick out only values that are greater than values greater than 10 or values greater than 5. So what do? I put an if condition if I is greater than 5. That's the only thing I want you to pick out. So print I. What happens here? It picks only the ones greater than I. So this is how, can you see how the indexing works? Can you see how the indentation works? So for loop basically just picks only the values inside the array. It just pull it out. If it's a condition that actually tells you to differentiate what you want it to do. So if you understand it like that, it's going to be easier for you. You work around these values. Easy. So now I'm going to use an example, just to explain this properly based on what we're doing, because I wouldn't want to stress us. So let me come down here. I think I have one of the file paths. So remember we have a file path where we have some of the data stored. We called it use data. So I'll come down here, I pick this guy, and I put it here. So this is the file path, right? Where we store the data. In your machine, you're going to have a file path like this. So I'm just going to import OS from our last class. You know what that means. It simply means, and if I do os.list directory and I do use data, now the first thing I'll advise you to do, you save this guy in a variable. You save B is equal to this. Now, if I print B, you could see it stores this value. These are all the far, like these are all the image names in that values. You could see inside the list. But how do you know it's a list? Always do this when you do, always do this. Always do print type of what you're looking at first before you start looking at it. So if I the type of B, what happened? It tells me what I'm dealing with. So it tells me that your result is stored as a class list. So if you have that information, that's all you need. So since it's a list, it's easier for me. I could iterate through the list. I could do for I in what happened? In B, print I. So you can see what happened here. It print it prints all the image. You could see these are all the image in that folder. This is just a folder part, so you're just picking all the image. But if I take this stuff and I try to plot it, I won't be able to see the images. It doesn't work that way, right? I'm going to show you what I mean. So let me show you what I mean. Come down here and pick. Just for you guys to understand better. Don't, don't worry about all this stuff. It's not your problem to worry about. I hope I see what I'm looking for. Okay. Forget about this, does not concern you. So I'm just going to keep it here so that you can see. I just want to use it as an example and show you. I'll keep it at the top here. Then I come back here and pick this guy. It's just a Python library that helps you visualize images. So keep it here. So now, if I come down here and pick only this image, just to show you that Python will not know what that is, because Python has to see the entire file path for it to be able to do something about the images. So what happens here? If I do this and I do PNG image, I'm going to get an error. But that image is stored in my machine. So it couldn't find the file path because it's saying there's no source file found. Now, what does this simply mean? You have to give it the entire file path to track. So for you to get the entire file path, what do you do? So I'm going to comment this guy. I'm going to come down here. I'm going to ask myself, what is the original file path? This is the file path. That means all of these images inside this list are stored inside of the file path. So what do I do? I'm going to say, okay, I'm going to call this full path. And for my full path, I'm going to use what they call a formatted string. And for my formatted string, I'm going to define use data, which is the path. And after I do that, I just have to put a slash in front of it so that it's nicer. Then I put the I, which is each of those values. Now, if I print full path, what do you think will happen here? It's going to store, it's going to pick, you could see, it has put the path for each of those images. So if I pick this image now and I give it to Python and say, okay, now that we have the file path, complete file path, can you show me what is inside that image? And let's see what Python would say. So if I come down here and hopefully, so Python shows you this is a core photo. So you could see how this thing works. So technically, it's not magic. It's just, what's it called? An image path given to Python. But for you to be able to get to the image path, we have lots of image inside that stuff. So the goal is basically to process it. Now, the trick here is what we're trying to do so far, what we're just trying to do is we want to build a dashboard such that we're going to label each of those images by their depth so that it will be easier for a reservoir engineer or maybe a petrophysicist or someone to just search based on the depth so that they could actually see how the core data is being arranged. That way they could actually tell a better story on how the subsurface looks like. That's what we're just trying to do. And the problem with this kind of problem is the fact that most of these core images are collected and stored in different locations. Some of them are stored in PDF files. Some of them are stored as JPEG images. Some of them are stored in PNG. This is simplest form because most of I think a processing phase has been done for these images where they are all stored as JPEG and it's easy for you to access. Now, usually they come in different variety of formats. Your job is basically to process each of those images, convert them to a pictorial format, and store them in a blob location such that we could easily store them in a database and consume the value in that database with their file path to a UI. Now, the trick is forget about all those plenty stuff. The major thing here is basically, assigning key components to it. One of the components you need to assign to it is one, the well name, two, the depth value. For this one, this might look a little bit difficult. Like if, let's say, not like it's difficult. This is 212, 213, 214. 215. We don't know what that meant. But because we know this image here, they already labeled this image that this sample was taken from 298 feet to 399 feet. That's where the sample was taken from. So that makes life easy for you. If I pick this other sample and I replace it here, so this other sample already is telling us that this other sample was taken from 399 4 feet to 399 5 feet. And all of them are from the same well. If you notice, the well here is well 64063_2. Now, this is just what I want you to do. Now, what we're simply trying to do is basically extract the metadata from the far part, which is basically what we're going to be doing. Store them in the data frame like an Excel file, then import that data frame inside a Postgres database. And that's all. That's just basically all. It's a simple problem, but it's a lot of work for. In fact, it's not just, it's a lot of work, trust me. It looks simple, but it's a lot of work, especially when you're having data from different formats. So what we're going to do here is basically, now you understand how for loop is being used. We're just iterating through a far part. This is use data. By listing all the values inside that use data, we got all this information, right? We got all this information. And when we checked, it was a list. And it was easier for me to iterate through that list to get all the information. So the next thing I'm going to show you now is basically where we're just, what we're simply supposed to do here is just basically write a simple, like a program that could actually just get us the depth and magnification. And that's simple. Now, sorry, the depth value. If I do, let me put the print here. If I do dot split, what do you think I'll get? Nothing, because I'm not splitting with anything. Remember in our last class, but if I split with forward slash, because there's forward slash here, notice what will happen here. Everything is splitted. Can you see how things are being splitted? Now, but what I'm only interested in maybe the well name, which is this one. I'm interested in this last value, like this value. So we know what the well name is. The well name is 640, like you can see the well name, like 64. So we're interested in only the last value. So how do we get the last value? I'll use minus 1, right? So what happens? It brings only the last value. Now remember also we need the far part. So we're going to keep the far part, full far part here. It's still here. So we need the far part because we need to store it together with the far part. Now, the next step here is basically simple. Now that we have this, so we're going to store this guy as, let's call it file to use. Let's see. Now, just to make our life easier, we're going to break it down. We know that we want to get a couple of things. One is the well name, which is this guy. And the other one, we want to get the depth value and we want to get the magnification value. So we're going to break it down. So we're going to start by using the word depth. Let's see, first depth. And for the first depth, what do we have to do? We just have to do dot split. Now, we're splitting by what? Underscore. Because now we want to split by underscore. So let's print this one to see how it looks like. So what are we printing? We're printing first depth. And if I do this, what happens here? You could see now I can take this value. Now, if I count from the back, this is -1, -2. So if I do -2, what happens here? I get first depth. So all the values here are first depth values. Now, I call it first depth values. Now, instead of me doing this, I can just take this value, this -2 here, so that I don't consume space and I keep it here. So automatically, if I print first depth here, I'm still getting the same thing. You see, append will become useful just now, first depth. And that's it, first depth is still here. So if I want to do for second depth, what do? I call second depth. And for second depth, what happens here? I pick what I did for first depth. I kept it here and I remove this guy just to see what it looks like. Print second depth. And if I run through this guy, what happens? I'm looking for second depth. Second depth is the last one. So second depth is -1. So I do -1, right? Then I get second depth. But you see, it has JPEG. So what do I do? I'm very careful. So because it has JPEG. Now, you don't just go and say split by dot, because sometimes you can have a value 4309.5. So you don't split by dot. So to be wise, I'll just split by what? J. I do dot split by J, just to be fair. So you could see J here. Can you see? And for this J here, what happens here? Now I can take only this one. Can you see? Then how do I take that one now? That one becomes position 0, right? And everybody's happy. Now, but what do I do about the dot? Now, since I have the dot, just for safety. So what do? I do, all I have to do is basically just do plus +0 to see what happens. So that when I convert it, I don't have issues. Technically this might work, or I could come down here and do dot replace. What am I replacing? I'm replacing dot with empty string. So nobody will know what happens there. This one is out. So I could take this guy as second depth, and everything I did there for second depth, I could just, I could just take this whole nuance I did here and do Control X, and I keep it here, and I print second depth and see if I'll still get the same answer here. So I've gotten second depth. Now, the next thing I'm going to ask myself, okay, since I have first depth and second depth, what else do I want? I need the well name. So if I print this guy, what am I printing? String value. And remember, it was splitted. So if I print the full, okay, now if I do dot split, and here for the split, I'm splitting by underscore. Now here, what happened? I don't want -1. I don't want -2. What do I need? I need from here to here. So remember, this is 0, 1, 2. So I'm going to come down here. I'm going to do 0 to 2. So, 0 to 3. So that it doesn't pick this guy. So what happens? Can you see? It printed everything the way I want it. So now, for this guy here, I can call this, what do I call this guy now? I can call this well name. Let's see, well name. But it's not complete. We want it together. Yeah. We want it. We can hear you. We can hear you. Can you mute yourself? So now we have well name, and the well name still has this information, but we don't want you to have all this stuff. So what do? We use something called join. And what are we joining? We're joining well name. So we're saying this is a list. We want to convert it. I think we've talked about join in our last class. So if I do underscore here, so it's going to join it back the way it is. So let's say final well name. So if I run this and I print well name, final well name. See, now the well name is this how it is now. Now, the trick now is basically how do we store this guy inside all of them inside an array such that we can convert them into an Excel sheet. So the first thing we're going to do, we're going to create different lists for all of them. So the first one is the file path. We call it a list. The second one would be the first depth, or let's say well name. Let's say well name. Well names. Let me call it two well names. I put it here. The second one would be the first depth. Third one, first depth value. First depth values. This one will be the second depth values. Now, by doing it like this, what happens? I have this information stored here. So I have all of them here. So all I have to do is come here and start appending. See how append works? I pick far part, easy. I put it here. I do dot append. And what am I appending? Full far part, full part. Easy life. Then what do I pick next? I pick well names. Oh, pick well names. Append. And what do I do? Easy life. I look for well name, which is final well name, the one we just final well name. The next thing I want to pick now is first depth. I do first depth that append. And what do I do next? I pick first depth that was processed, which is this one, right? I just take it, append this guy. The next one, I'll pick. Did I spell append properly? Anything I didn't spell properly, let me know. So sorry, first depth values, the one outside. Yeah, first depth values. Now the next one is second depth values. Second depth values. Then I append, and what am I appending? I'm appending um second depth. Just everything the way I want it to be. So life is easy. Now the trick is, by doing this, if I were you, you ask me, what's the best way to store this information? You know, so this is where data frame comes into play. So data frames will help you store something in a way that it is easier for you to convert it into a comma separated value sheet, which is what you call Excel. So I can print these values, but if I can't store them in a structure whereby my superiors will look at it and they can easily handle it, what's the essence? So now I'm going to import data frame. So notice that pandas as PD. So pandas is basically a Python library that helps you walk around with data frame. So what happens here? I import pandas. You have to must have installed it. If you have it, pip install pandas. I hope I have it. So, and I'll just do pd.data frame. And for my data frame, what do I do here? I can start with the first one, a dictionary. I can say, sorry, I think. Someone, so I'm coming, someone just sent me a message. So for this data frame, what do? We want to arrange it properly. So we want to start with the file name. So we can come here and say file part is in a list already. So I can say, let me make it easier for myself. So I can say file part. And for the file part, what do I have? I have this. Now I do comma. The next one here, well names. I pick well names. I see well name. And for my well name, what do? I just replace it with this guy, well name. The next one here would be first depth and second depth. I'll call this depth, let me call it top depth, top depth. And what do I put depths here. So I put everything here. There are different ways. Like I wish I had more time, so that we could actually this is not a software engineering class. So I would have explained how pandas really work, like from the very core, you know. It's not just used only to run Excel sheets or so the next one is I have bottom depth, and all I have to do is just put this guy here, and if everything works properly, this first depth values, I didn't put a comma here, I think. So let me call this df1, and hopefully this works. df1. So df1. So if it doesn't work, so obviously I must have done something wrong. So you could see everything worked. So you could see you have all the far parts stored here. You could see the well name stored here. You could see the top depth stored here. You could see the bottom depth stored here. Now, you see what you just did here. This is what we call a classic way of storing core data, where the part where the file, the images are stored is placed inside the sheet where you're supposed to load with. That way, if I store this in a database, all the UI has to do is retrieve the file path and it will just plot the images using the PyEL image. So I could plot the image as much as I want to plot the image. That's not even a problem because I can build a simple UI with Streamline and plot it. But the most important thing is basically storing the depth together with the well name. So I could basically just do a value count to check how many wells we have here, and I can see the maximum and minimum depth for that well. So I could do a couple of things with this information, but the most important thing is tying it back to the original image, because in how will I put it? One of the processes of characterizing what's it called, reservoirs, is basically seeing, it's actually the petrophysical study. And one of petrophysical study is basically, you're dealing with, correlated images. And those correlated images can range from, thin sections. It can range from what they call scanning electron microscope images. We call it SEM images. And also one of the most important ones, which is the one you're seeing here, we call it core photos. Without these images, you really can't see even if you do a scala analysis, and you have porosity variability, working really fine. And you can actually basically predict, okay, yeah, this is a proper reservoir. But without actually seeing the the images, because during drilling, these images are captured and stored. So without actually seeing the images, you can't really that whole process cannot be qualified. So one of the jobs you'll be doing as a data analyst is basically cleaning, processing images and storing these images in database, for reservoir engineers to actually take a look at those images, on dashboards, compare those images to the analysis that have been done for other types of, let me call it data types, other types of data types. For example, let's say, for example, you could do a routine core analysis, so they have to be, it's a comparative study when you're dealing with geology. So you're looking at this, you're looking at that to see if everything tallies. And it might look like a simple thing, but it's a lot of work, especially when this is a simple example, because now the far part, I've already given you the far part, the images are all stored in the same place. Sometimes we don't even know where the images are stored. They are stored in reports. So you start looking for the reports that have those images. You start writing Python codes to pull out those images from those reports. You start looking for a way to attach those images back to the well name. You extract the top depth and the bottom depth from that images. So you could see you have to define an entire workflow for that process to be done. And it's your job to do it. So it's not a very fancy job. You have to learn how to code. So this is just the first step so that I don't bore you guys with what we have to do. I'm going to give you assignment based on this, just to see how you capture, how you're following what I'm trying to say. So that in our next class, we'll start looking at how to move images, visualizing these images, something simple where we could actually play around with. But for now, I would give you some assignment to see what you can do with this image. And so sometimes notice For some of them, the depth information are stored inside, like their pictures inside the image. So you have to find a way to extract the what's it called? The value from the images itself. Now, for you to do that, you have to start using advanced tools like setting up, what they call Pythagoract. And now we have LLMs. You could actually play around with it and to help you with that process. But before, what we do is basically set up what they call Pythagoract, extract the image text and store as an array, then use regex to find, to map the numbers, like the values, so that we can actually pull out all the values. So it's not the fancy stuff. You need to learn the basics first for you to be able to do it. So, and also to this, not only how pandas work, pandas doesn't just take dictionary. Pandas can take array. It depends on how you play with pandas. But for now, I won't go into that details. I will just wait for you to ask me questions. So anybody has questions for me? I don't want to bore you, so I can give you assignment and you could walk through the assignment. Let me see how far. It's already 9 o'clock. Anybody have questions for me? You have to ask questions because the assignment now, you guys have to actually do it.
I have a question, sir.
Please ask your question. Yeah.
So I want to ask that we're still using the same environment because I'm seeing introduction.ipymb and day one ipymb.
Yeah, for me, it's my environment, the one I've been using. The environment wouldn't change. Why would you think the environment will change? Why did you ask
I,
that question? I think I need to understand why you're asking that question because
I'm
from the
seeing
question, yeah,
two
from the way you're
files.
asking the question, there are two things that's my problem. Now, my problem is that you don't understand what we've been doing, like from the start, because that question is a very, 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 very 10 days ago question. But it's still a bad question. If you don't understand what we're doing, just tell us.
I
And
understand.
yeah, we're using the same environment. Right from time, I've been using the same environment, For I could create multiple Python file as much as I want here. Are you getting me? So it's not a problem. So I could create an environment and create multiple files and play around with those files. In fact, I could create folders and store files inside, create configuration files, whatever I want to do, I can do it here. So that's not a problem. So I'm using the same environment here. I just told you guys to, walk around the environment. Samuel, you have a question? Wait, first of all, Oluwa Ferami, did I answer your question?
Yes, sir. Yes, sir.
Oh, okay. Samuel, please.
So I don't know if we have access to these files, like
Mm.
this file that has all these pictures that you're
Yeah,
using.
yeah, yeah. I shared it. We already shared it. So download those, download. I shared it with you guys. If you're using a Windows, it's going to be different format. So you need to learn how to pick out the images from those files yourself. Let me see if I still have, let me see if I can share my email. My problem is you guys seeing my email. Let me see, 1 minute. I'm coming.
Okay, sir,
Okay.
sorry.
Yeah.
Sorry for interruption. So the file, I sent it. I sent the link in the WhatsApp group, and I asked everybody to download it and get it ready for this class. So Samuel, you can go back to the chat, to the WhatsApp group that you are in. You can see the link. Then through the link, you can download the files.
Okay, yeah, I've seen it. Because I was seeing it.
My problem is you guys will be looking at my email. So let me just see if I can show you how those files are sorted out. I hope I'm in the right place. Yeah, okay, that's it. So this was shared. I think which company shared this? They were doing one a hackathon project with NAPI. So they shared this repository. So it's a public geoscience data where you have lot of. So we just picked only the public core images, and I shared particularly the ones I wanted you guys to work on. So these are most of the images, if the ones I wanted you guys to work on. Let me see. I wanted to show you something. Like in real life, like this is the kind of things you have to deal with. You can see In real life, yeah, you'll be dealing with lots of information. This like an example of a call log. And for much complicated tasks, you might be asked because at the end of the day, most geoscience workflow, data has to be stored in databases. That's just have that at the back of your head. That your job as a geoscientist is, at least if you're just finishing school, is making sure you optimize or making sure processes are more efficient for senior geoscientists to work through. Forget about analyzing or building fancy stuff, machine learning. That's not your problem. Don't worry. Trust me, it's not your problem. You know, your problem is making sure that the way the data is, that's how it should be in the database. And that process itself is not an easy process. You could see this is like a call log, like samples of call log. You can be given this particular folder, and what the question would be is these are PDF files, but they just want the core intervals, and the recovery percentage to be stored inside a particular table in a database. You have to find a way to do it. So first of all, things you need to pull out. They say they want the well name. They want the date at which the coring was being done. Maybe they want the coordinates, or maybe they want the total depth of the logger, and also they want the core interval. So you have to start writing code. So the point is, if the format for this particular one, this is a PDF file. Now, if the format of the PDF file is the same, because all of them are from the same company, it's easier for me to just write a function that could pick out the well name, pick out the date, then pick out the core interval, and process that information and store them. Now, you can say, oh, can this be done manually? But the problem is you'll be working across 10,000 and 20,000 files. Sometimes you can't do it manually if you have a project that's just lasting for just 2 months or 3 months, and they need to start analyzing data as much as quick as possible. So you need to write code to do it. This is a different project I wanted you guys to look at, but I don't think we have time. I just went with the most simplest one. The simplest one is, forget about interpreting it. Like, if I show you how geoscience dashboards work, you need to, as a geoscientist, you need to understand how data is being moved and stored. That's the first phase you start from. When you start understanding that phase, analyzing the data won't be a problem to you. Because you are the person that understand the workflow of how data is being stored. That's why they start you at that level. You start from, ETL processes, which is extraction, transformation, and loading data in databases. After then, maybe 2-3 years time, you start working on quality control problems where your juniors still work on the ETL processes. If you want to switch into a small data engineering part, you start building, scalable system to handle those data storage services to make either searching easy or to make whatever it is easy. Like we can move into the software engineering side or data engineering side. If you want to switch into the data science side, you start building machine learning models, based on the data stored in database. That means you started entering senior, small. If you want to still work in data engineering, you start working around building complicated data models on how, as data is coming in, how those data will be stored in different schemas and tables, and how that can be better reflected in the dashboard. If you want to still be in data science, you start, working around complex models in machine learning, on how best to actually understand the reservoir. If you want to follow like a geoscience, like you want to be a geoscientist the entire time, all you have to do is just move into understanding, the data in the dashboard and how you can actually leverage on, what the dashboard is telling you, to make decisions on the reservoir. So you need to, at the end of the day, at least for 2 solid years, you need to basically walk around the messy part of the process, which is basically write codes to pull data out of this process. So it can be complex sometimes, especially when you don't know how to code. That's why I'm begging you guys to just, like, we're just walking around core images that has the depth value stored inside the file path. So that's like something like if they give it to you, you're expected to do it before lunch. Actually, you're expected to do it before lunch. They just tell you, hey, do this quickly, let's get it done. So you can't be struggling with that because you don't have the basis of programming. So what I advise you to do is basically just I think I'm just going to share the entire, and I'm going to share you the projects, So at different levels, you have different projects you can work on. So don't rush into trying to work on complex machine learning stuff when you don't know how to work around data, understand the type of data types we have when it comes to dealing with geosciences. When I mean data types, now I'm talking about the types of, analysis, the types of what's it called, laboratory analysis being done, and the kind of data that is used, if you want to work in production, basically. It depends. If you're a field person, that doesn't concern you. So the point is, if you want to work in the office, so the point is you still need to learn how to code. I don't know how to tell you this, So I think the one I shared was mm, caustics. Yeah. I think I shared something like this. Just follow the path I sent, and I think I shared some stuff. And this is quite simple, The information is already here. So I don't like, and you have core logs, you have core images. We tie those information together. We see tied to petrophysical. We call it curves. So, like I said during the first class, one of the beauty of being a geoscientist is the fact that you're a scientist. That's just the beauty. Your thought process is tied around different experimentation, different processes. So you're not just making decisions based on just one thing. So you're looking at this, you're saying, okay, how do I relate this to this? And where does it make sense? So there are a lot of things you're looking at. I think I picked a couple of the data and I explained how they interplay with each other and how we make decisions based on that information. So, but the bottom line is you need to learn how to work around files, process files, pull out information from files, store them in database, understand database schema relationship. That's why the final thing we're going to do is basically just build a simple database, import the data we've extracted and store them inside that database. That's all. So I would let you guys go, but before then I'll just show you the assignment you do for me. Just to know he's serious. Lecture up classes, I think. Yeah, so um these are call logs. These are call log. No, you're not doing this one. These ones you guys will not do it. If I give you guys this, you guys will not even come to the class the next time. Yeah. Rias, you have a question. I'm looking for.
Good evening, sir.
Good evening. Yeah, I can hear you.
Thank you so much, sir, for the session.
Mm,
And we are really grateful for this information.
mm,
Now, my question here is from the beginning of the lecture, I have some network glitches.
what's the
So,
glitches?
network glitches.
Your network. Okay.
So, I don't get the beginning of the lectures, even though at the middle and at the end, I
Mm,
understood most of the programming context.
okay.
So, are we going to have the recordings after the sessions,
Yeah.
or I
Yes,
just
please.
have to go and
Yes, Ugochi would help you with that. Ugochi, you would make sure everybody gets it. Ugochi, is that true?
Yes, sir, that's true.
Okay, so
thank you so
yeah.
much, sir. Thank you.
I'm going to share I think there were 3 file parts. I don't know now. I can't even operate my computer again because I'm confused. I'm tired. There were a couple of file parts I shared, like a desktop here. So I have core images. No, there's the one not this one. I don't want you. I think here. This is another. Yeah, this is a well we processed. This is another well. Yeah. So this is, I think. Yeah. I think. Yeah. Good. This one is good. So what I want you to do is go to this particular well, 6506.12.5. I want you guys to replicate the same thing I did for this well, right? For this particular well. Just store it in the data frame too. Just the same way I did it. That's all. So go through the file path, look at the well, and just do it. Then I'll show you how to combine information together and how we can actually, I just want to make it as simple as possible. In the previous session, I was showing you how to create, storage location and moving, images to that. So I think that's going to complicate your life. But for now, just repeat this process so that in our next class, we'll be thinking of building interactive dashboard. It might not be interactive because you don't have time, but thinking of doing two things, creating a database, storing this information in that database, that like the data frame we just created, and seeing how we could actually, consume the information in the database in a small dashboard just to see the color. So we could search database using a UI to see when we say we need core images between let's say 3,500 to 4,000. It'll just bring them out as images and arrange them for us. So we'll see how we can actually consume images like that, and because that's basically what you're going to be doing in industry, because sometimes when they are not sure about what happens in a particular depth, they want to find out, okay, do we have core images for this? Let's see if what this our analysis is telling us is this. Okay, from this depth range, let's see the core image and confirm what our analysis is telling us. It's just a lot of complicated stuff. Now, do the same thing I did for what I just did for this guy, and I'm going to look at it. Ugochi would tell me everybody, Ugochi, you're going to create what's it called? I don't know. You're going to create a folder in the cloud. Anybody will submit it with your name. Like the Python file would be your name.ipynb. You put it there for me and I'll look at it. And if you don't submit it, I don't know. It simply means I've wasted my time. So and that will not be fair for me. So I have other things to do. I should be chilling this Saturday, having a glass of whiskey, but I'm here. So I'll see you guys next week. Is that okay? Question?
Yes, sir. But let me understand what you said. Like after they have submitted, they will submit with their names, right?
No, they
Then
won't
I'll
submit their names. They'll submit the Python notebook would be their name.
Okay.
Yeah, like more like you see how I said introduction.ipynb. So
Yeah.
yours is gonna be Ugochi underscore Mary Jane dot ipynb.
Okay. Then I will submit to you
You
before
just
that.
put it in the like in the folder in the drive, then share the part with me. That's all. Their job is just to put it there. Or they can
Okay.
send it to you, then you can put it there. They can send it to your email, you can put it there so that they will not go and put it there and see someone else's work and copy the person's own. Yeah.
All right, sir. Okay.
Okay. Are we good? Any more questions before I go?
Yes, sir. I have a question, sir.
Please ask. Yeah.
Okay, the question I have is concerning the data frame we created.
Mm,
So I noticed that after we created the four well name and the
mm,
other values as well, there was
mm.
a separation and there was another value there
This
that
one.
increased down. Yes, sir.
So
So
it's not a
that's the part I
separation.
don't understand.
It's
Yes,
still the
sir.
same thing. It's just that your notebook cannot see everything. Are you getting me? So it's just like one, two, dot, 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 dot. So you cannot see everything. So I can do, normally I'm supposed to do df dot head 20 or 30. It's going to be very long. So this doesn't make sense. So if you just type Python df the head, it shows you the first five and the last five. Are you getting me? Then it shows you dot, 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 dot. But if you want to know the shape, that means how many data that was stored here. All you have to do is df.shape. So it will tell you how many you have. So it's telling you that you have 294 images and also four rows. What's four rows or four columns? 1, 2, 3, 4. So in our next class, I know there's a lot of things I haven't picked up on. We're not even writing clean codes because you guys don't know. We don't know functions. I'm not taught you functions. There's some context. There's some things you need to learn. It's not everything I can. Like you just have a few days to do this. And I don't know if I'm the best person to motivate you. I've seen how the Chinese they behave. And I've seen how Africans we behave, especially we in Nigeria. It's only when we travel out, that's when we're the smartest people. But in Nigeria, we're so lackadaisical, especially when it comes to learning. If it doesn't come to your doorstep and someone is not holding your ears or begging you or paying you money to do it, you don't want to do it. But there's this habit with the Japanese and the Chinese, they just want to be the best. And it's scary because every industry, especially when it comes to technology, wants a Chinese person on their team, want lots of Chinese people on their team. And you wonder, when we have lots of research institutes in Nigeria, what are we actually researching? So the point is, I don't want you to be one of those kind of students where, you don't want to put in the work, you don't want to learn on your own. It's only what is given to you, that's what you consume. Don't be like that, Don't be like that. The world has gone, but you have every resources to learn whatever you want to learn right now. So if you want to make yourself, if you just want to be there, it's not fair for you to. So I don't know how to advise you. Just do it, just do it for the sake of your career. Most of you are just finishing school, and it's good for you to start picking up this kind of skill set. Still okay?
Yes, sir. Thank you so much, sir. Thank you on behalf of everybody. We are really grateful because there is a lot of difference from what we are doing now and what we did before. Because I feel like is entering. We are, especially me, speaking on my own side. I'm understanding it very well, unlike the previous
First time,
classes.
yeah. That was the first time, yeah. I understand.
So thank you so much. And yeah, for the assignment, so it's going to be one of the criteria for giving each and every one of us certificate. So if you relax and you wouldn't want to partake in the assignment, just know that you will not be getting your certificate. So it's very, very important, not just for the certificate, but also to be proud of yourself. You can't spend hours, spend your time without getting something or without being able to do something that you are going to be proud of in the future or nearest future. So let's all of us attempt this assignment. Try, just try. Let it not be that, oh, you did and you couldn't do it perfectly. We are here to learn, and so don't feel shy. And yeah, so the assignment, I think the deadline is going to be Friday, so
Yeah,
that before Saturday, everybody must have submitted his or her assignment. Okay, I feel like that's okay.
that's all. Okay. See you guys next week. Have a lovely weekend then. Take care.
All right, thank you, sir.
Thank you. Thank you. Bye.
Thank you, sir.
Bye.
Thank you so much, sir.
All right, everyone. Good night. I'll end the call now.